Hello again. We're here to talk about recursive reporters, Unit 8 from BJC. Once again, I'm not going to necessarily do exactly what BJC says. I'm just going to do my own little vague introduction that hopefully covers the same concepts. So the key idea of a recursive reporter and the thing that makes it recursive is that I'm going to have two here. We're going to write somewhere in this reporter, you're going to find itself. You're going to find this reporter within itself. That's one of the key things that makes this recursive. So let's start with this count letters in list input list. So the idea is I would plug this list into it and it would tell me how many letters are in that list in total, however many that ends up being. While I'm at it, let's go ahead and make this input into a list. Remember that great little trick right there. Okay, now how are we going to do that? Well, the first thing we're going to do is we're going to count the letters in the first item in the list, and I have code that does that. I can just do, remember the green length of is the one that tells me the length of a word. Count the letters in item 1 of the input list. There it is. Okay, so that will tell me how many letters are in the first item of the list. Now I'm going to add to that the letters in item 2 plus the letters in item 3 plus the letters in item 4 plus the letters in item 5. In other words, I'm going to add to that all the letters in everything else. So this is a little bit crazy here. I'm going to add to that. I'm going to count the letters in the list, everything but the first item, which is the reason why this block exists. So you can do exactly this thing. I'm going to count the letters in the list all but first. So it'll count the letters in item 1, and then it'll add to that the sum of the letters in all the rest of the list until it gets to the very end of the list. If I do this right now, this is not going to work. It's going to run forever. It's stuck in an infinite loop because it gets down to the letter to count letters in list all but first. And when it gets to the last word, Agnew, and it goes to count the letters in the list of everything else, there's nothing in that list and it doesn't know what to do. So it's stuck. So what I need to say is, okay, do this if and only if the list is not empty. If I give you a list with nothing in it, you can just report 0 and we'll move on. So I'm going to throw a big if else here. And if the list I've given it is empty, and there's a few ways I could do this. I could do if length equals 0, whatever else. If the list is empty, then just report the number 0 because we know there's no letters in the list. Let's try that. There we have it. There's 38 letters in AP Computer Science Principles with Mr. Agnew. So that's a recursive reporter to count. If I give this first part's called the base case. If I give it an empty list, it reports out 0 because there's no letters in it. Otherwise, it finds the length of the very first item on the list and it adds to it its own operation applied to the rest of the list with that first item removed. That's the idea behind a recursive reporter. Let's do another one that's more mathematical. So the Fibonacci sequence, 1, 1, 2, 3, 5, 8, 13. The sequence is you add the previous two numbers together to get the next number. You start with 1, 1. 1 plus 1 is 2, so the next number is 2. 1 plus 2 is 3, so then it's 3. 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 5 is 13. 13 plus 8 is 21, etc. That's the Fibonacci sequence. I want to make a block where if I plug in 10, it gives me the 10th number in the Fibonacci sequence. Well, it's the sum of the previous two numbers, so it's just going to be the sum of the number right before this, which would be Fibonacci number n minus 1. If I'm on number 10, it would be number 9. Added to Fibonacci number, let's duplicate that, n minus 2. Add together the two numbers that come before. That's the Fibonacci sequence. To get number 10, add number 9 with number 8. Except what happens when I ask it for number 1? It's going to add number 0 with number -1, and it doesn't even know what those two are. I've given it no place to start. So once again, I need the base case. Just like here, if input list is 0, Here, I want to have a base case, although I actually need multiple base cases here because both the first and the second item of the Fibonacci sequence are 0. So I might just say here, let's do another if. This will be going the else. And then this will be, I want items 1 and 2 to be 0. So I'm just going to say if n is less than 3, which would mean items 1 and 2 would both be 0. If n is less than 3, and then what it's going to report out, the first and second items of the list are in fact the number 1. So it's going to report out 1. All right, let's give this guy a test, see if it works. Item 1 should be 1. Item 2 should be 2. Should be 1, excuse me. Item 3 should be 2. And then 5, 3. And then 5. And then, oops. Stop. I've killed it. And then 6. Item 6 is 8. Item 7 is 13. You know, there's an easier way to do this, to test this. Let's bring the sprite over here, and let's have it go. 4i goes from 1 to 10. Let's have it right. Fibonacci number I, size 12. Look at that. I could even throw in a move 2 steps after each one to give a little bit of spacing. And there's the Fibonacci sequence, well into the hundreds, just like that. So those are recursive reporters. The key elements, they've got a base case where if it's the simple enough situation, like an empty list or the first couple items in a sequence, there's a set thing it reports. Then they have the recursive case where it calls itself. Its own function is within itself with some operation done to it. What that operation is depends on the specific situation involved, but those are both examples of recursive reporters. Best of luck with Unit